Okay, so you guys, a lot of you guys are asking about how to graph logarithms because you've forgotten already. Alright, but don't worry, I hope this tutorial video will help you. You can watch the other links that I put on Schoology, and those will help you with the basic logarithms, okay? But these are with its transformations. So I specifically want to go over the number 12 over 12a, number 12a, which is actually in your worksheets, review worksheet. So please follow along. I'm just going to give an explanation, a verbal explanation along with your solutions, okay? So your given function, I know it's pretty ugly. 6 plus 2 logi base 6 and x negative x minus 3, okay? Just really briefly, let's actually rewrite this so you can see it better, okay? So it's g of x is equal to 2 logi base 6, and look at what I'm going to do. I'm going to factor out the negative here so you can see the transformations within the horizontal. Everything inside this parentheses here, it has to do with left or right, horizontal. And everything outside, like these guys, they affect the y value, which means the k, right? So hopefully you understand what's happening here. But you remember the key thing for logarithm graphing is to plug in for the y, not the x. That's how I do it, but maybe you have other ways of doing it, okay? So see if you understand there's a vertical stretch of factor of 2. So there's a vertical stretch, right? Write this along with me, okay? Vertical stretch of factor 2, right? So this is what the notation means. A stands for the horizontal, right? A, x value, and B, that means we have horizontal stretch of 2. There's a reflection, right? Where does the reflection show? Right here. That's the reflection. Reflection in the y-axis. Because every x values once used to be a 3, now became a negative 3. So you know there's a reflection in the y-axis. So it becomes negative a to b, okay? Because there's a reflection in the y-axis, which means that the x coordinates is affected. There's a vertical transformation of 6 up, right? 6 up, that's this guy right here. That means it's negative a to b plus 6, because it went up 6. All right, and next, last but not least, horizontal. There's a horizontal transformation, transformation of, remember, this actually refers to, but it's a negative outside, so it's going to be left 3. Go back to your notes, and you will see, you guys, I gave you all the standard forms with the transformation, so check that out, okay? So now you have this. Now, what else does this tell you? This right here should tell you right away that there is a vertical asymptote. Make sure you look at the notes from the previous days on what a logarithm, basic logarithm, y equals log e x, what does that look like? It looks like this. Okay? So there's always a vertical as, and there's a vertical as where when this equals 0. So a is going to equal negative 3. Right? That's your vertical asymptote. All right. So knowing that, you should have an idea of the graph. What I like to do is I like to start with the STD form. You guys, the parent function of logi base 6 is going to be y equals logi 6x, right? So in other words, exponentially, it's 6 to the y has to equal x. So instead of plugging for the x, let's plug in for the y to get the x. So actually, let's do that, okay? So there's a table that I create. And this is going to have, right, it doesn't matter how you do it, but I'll just keep it consistent to the solution sheet so you understand the solution sheet, okay? So this is going to be AB without the transformation. So let's plug it in. If I plug in a 1 for the y value, 0 for the y value, plug in for the y. So I'll put a note here. Plug in for the y values. Okay, it just makes it easier. So plug in y for 6. Plug in y, 0 for y, 6 to the y is what? 1, right? How about when you plug it up? So let's go in order. 1, 2, 3. And if you want to try some negatives, you can try some negatives too. So you know what, you guys, let's do it this way then. If that makes you feel better, let's go ahead and do this. I'm going to change it up a little bit from the answer sheet. So I'm going to go 0 here, 1, 2, 3, 4, and then let's do some negatives too, okay? So let's start from here. We get negative 2, so it's 6 to the negative 2, it's just 136, right? Negative 1, 6 to the negative 1, so it's negative 1, 6, right? Just plugging in value. 0, you get 1, because anything to 0 power is 1. 6 to the 1 power is 6. 6 to the 6 squared is 36. What's the next one? 216. And the rest is history, okay? We don't need to go that far because we now have a general idea of what this graph looks like, right? So you guys, let's actually plug that in, okay? This is the parent. So 6 to the y. So ready? We go. And I'm just going to do a general sketch. And as for you too, I don't need a perfectly scaled graph on any of your homework assignments, okay? So 1, 6, 36, negative 2. Ooh, like really close to here, okay? 1, 6, negative 1. Ooh, like right here. 1, 0, 6, 1, 2, 3, 4, 5, 6, 0, 6, 1, I'm sorry. 36 way over there is 2. So you can see that this general graph has an asymptote of 0, x equals 0, I'm sorry. And it goes on forever that way, okay? And our other graph, with the transformations, it's going to be negative a, I'm sorry, let's do that again, okay? Negative a minus 3, right? Sorry. Negative a minus 3, oh God, okay. And 2b plus 6, right? And that's exactly what we identified here. And you just apply that to this, okay? So let's actually write all the coordinates here. Let's just go with the easy ones here, okay? So 1, 0, it's going to be negative 1 minus 3, which is going to be negative 4. 0, it's going to become 6. Do you see that? And that's actually our new starting point, isn't it? Okay. I mean, well, new key point. We're going to talk about key point. 36, negative, oh, I'm sorry, let's go to 6. Negative 6 minus 3 is negative 9, right? Everything gets shifted. Multiply 1 by 2 plus 6 is going to be 8, right? 36, negative 36 though, minus 3 is negative 39. And 2, 4 plus 6 is 10. 2, 16. And the rest is history, actually. Negative 293. Let's try it, okay. Negative 2, 16 minus 2, so negative 219. And 3, 6, and 12, okay? And you see how that's growing. And here too, negative 1, 6 minus, so it's going to be negative 3 and 1, 6, right? Negative 1, negative 2, positive 4. And I mean, you could actually guess what this is going to look like. Negative 136, negative 3, so negative 3, 136, right? And you can do that on the calculator too if you want the extra actual decimal values. Negative 4 plus 6 is positive 2. So you got to graph that. Let's graph that together. Let's just start from here. Negative 4 and 6. 1, 2, 3, 4, 5, 6, negative 4. Negative 9, it's all the way up there. We know it's going to look like it's reflected, right? Negative 3, 6, 1, 6, negative 3. 1, 6 maybe about here or so, okay? Oh, I'm sorry, 4 though, right? Sorry about that. Okay, it's 4, so we're going to go here, okay? Oops, yeah. Negative 3, oh, I should go a little bit to the left more, right? Negative 3 and 1, 6, about 4, okay? Negative 4, I'm sorry, negative 3 and 136, and it's going to be positive 2, so it's about right here somewhere. But you can see how it's going to look, okay? Gonna go. Sorry about its ugliness. Let's try that again. Sorry. Okay. Negative 4, 6. Negative 3, 6, 1, 6. Ooh, negative 4. Okay. Negative 3 and 1, 6. It's about right here. Let's just exaggerate. Okay. Exaggerate a little bit. So it's 4 here. Negative 3, 1, 6 is about right here somewhere. Okay. Oh, that was what it said. Plus a 2. So a little bit further down. I'm going to just adjust this point here a little bit. So again, yeah, it's a little tricky, but you should have a general idea of what these graphs are going to look like, okay guys? Alright, so let's actually go ahead and graph that sucker, okay? You see how it's going to be reflected, but where is it going to actually shift? Let's try it. Negative 9, it's going to go continuously, but remember, there's an asymptote at negative 3. So that should tell you what it's going to look like. Okay, there's an asymptote at negative 3. X equals negative 3 asymptote. Okay, so you guys go ahead and graph that. It's going to go, once you draw the asymptote, it's pretty clear, right? What it's going to look like. Let's follow that. It's going to go on forever that way, like that. Okay, so you guys go ahead and try that. Apply the same concept to the any other logarithm graph. This is the hardest it's going to get, right? Really, okay? All right, good luck. Bye.